6.2b, apply properties of rational exponents. Awesome. Okay, when you are dealing with exponents, you need to make sure that they have the same base. Notice this base is 5, this base says 125. Okay, so you need to try to make these bases the same. So, could I break 125 down to 5?
Yes.
Yes, because this breaks down to be 25 and 5, and then 25 is 5 and 5. So I'm going to rewrite this problem now, and I still have 5 to the 4th power times, I'm going to write this as 5 to the 3rd, and since there's an x here, you multiply anything together that's up there. So that's going to end up being 3x, because 3 times x is 3x. If your bases are the same, we add the exponents. Okay? Do you guys remember that?
Yeah.
Because remember, hold on, if I had like x to the 3rd times x to the 2nd, these bases are the same, what does it make? X to the 5th. The same things work for numbers. Okay, so these bases right here are the same. They're both 5s. So all we do is add the exponents together, and I get 5 to the 4 plus 3x. Because I can't add 4 and 3x together, so we just write it as 4 plus 3x. And that's your answer. Okay. Questions on example 1? All right, example 2. Notice these both have a base of 2. Okay, so what am I going to do with the exponents? Add them. Okay, but here's my issue. When you're adding fractions, they need to have what? Good. So I'm just going to write the fractions here to the side. 1/4, we need to add 1/4 plus 2/3. What would be my common denominator?
12.
Okay, so I'm going to write this as a denominator of 12. And what do I multiply 4 by in order to make it a 12 denominator? 3. And whatever you do at the bottom, you do at the top. And 1 times 3 is 3. Here, we have 3 times 4 makes 12. So 2 times 4 makes 8. And then we can add those together, and we end up getting
11 over 12.
11 over 12. So my answer is what?
2, 11 over 12.
And that's your answer. Okay, questions? Okay, example 3. What, could I write 8 as a base 4?
No, right at 2.
Good, no, we can't, but we can change both of them to be base 2s. Do we agree with that? Because if you did 4 to the 2nd power, 4 to the 2nd power is actually what? 16, not 8, right? Okay, so we're going to change 4 to be what? 2 to the 2nd power. Now remember that you already have a 1/3 there, so you're multiplying by 1/3. So that actually ends up making 2 to what? 2 to the 2/3, because you multiply tops with tops and bottoms with bottoms. Okay, so that's 2 to the 2/3. Are we okay or no? So you already had a 1/3 here. We changed 4 to be 2 squared, which is 2 over 1. 2 over 1 is the same thing as 2, and you multiply it by the fraction that's already there, which was 1/3. So 2 times 1 is 2, 1 times 3 is 3. Okay? Now 8 is going to change to be 2 to the what? 3rd, or we can write that as 3 over 1. Okay, 8 is now changing to 2 to the 3rd, or 2 to the 3 over 1. But you already have a 2/3 there, so we have to multiply it by the 2/3. Now, if you notice, those could end up reducing, and you could just have 2 to the 2nd power. But we don't want that, because we want to have a common denominator. So I'm just going to multiply, and this is going to end up becoming 2 to the what? 6 over 3. Then what do I do? Add them. And we add them together, and what does it make? 2 to the 8/3. Or 8 over 3. And we're just going to leave our answer like that.
The next one you just add since it's relative.
Okay, so if you're, are we okay on example 3 before I move on? All right, on example 4, if your roots are the same, you can add them together. Well, what number is really in front of that root? 1. So we can add those together, and what does it make? Good. You keep the root the same. All you're doing is adding what's in front. They're all saying still the 4th root of 10. Could I break 10 down to get any 4 groups of 4s out? No? Okay. So that's our answer. Okay, example 5. Do those have the same roots?
Yeah.
So we have 2 minus 5, which makes what?
-3.
So we have -3, and then I have the cubed root of 54. Do you guys know if 54 can break down to have 3 of anything?
9 and 6.
Okay, so I think so. So let's break it down. So 54 is 9 times 6.
And it has a
9 is what?
3.
3 and 3, and 6 is 3 and 2. So it looks like I have 3 3s and a 2 left over.
Is it -9 square root of 2?
Yeah, cubed root of 2. Exactly. Yes. So we bring that group of 3s out, and there's already a -3 there, which means we multiply them together. So that's -9 cubed root of 2. We good? Okay. Do these ones have the same roots? No. So we're going to have to break each of these down right now and then see if we end up having the same root that we can add them together. If they don't end up having the same roots, then you just won't end up adding them together. Okay? So 25, what does that break down to?
5.
Okay, 5 and 5. And how many do I need for a group here? 2, because it doesn't say, so it's automatically a 2. So I have a group of 5s. And then how do we want to write out x to the 5th? We have x squared, and x, because that really makes x to the 5th, right? And we need 2 for a group. And we have an x left over. So let's go ahead and rewrite this one. So what is my first term going to end up becoming? So you have this 5 here, and you have a -9. Nope.
5x.
This is going to end up being -45 because we multiplied -9 times our 5 that we're bringing out. I already have an x squared, and then I'm going to bring out 2 more groups of x's. So that's going to make x to the 4th. Because I have 2 here, and I'm bringing out 2 more.
And underneath the root stays the x.
Good. And then we have the square root of x.
At least I got them.
Okay. So now 49 breaks down to what?
7 and 7.
Okay, so we have that group. And then x to the 9th we're going to write as?
X to the 3rd and x to the 3rd.
No, we're writing them in x squared because we need 2 for a group. So I have x squared, x squared, x squared, x squared, and x. And double check to make sure it makes 9. So 2, 4, 6, 8, 9. So when I bring those out, I bring the 7 out with a 3, and that multiplies, and it makes what?
20.
So we have 21. And then how many groups of x's am I bringing out? 4. So that's going to be x to the 4th because I have 1, 2, 3, 4 groups I'm bringing out. You get 1x per group. And then left inside, I still have the square root of x. Can I add these together now? Yeah. So -45 and +21, what does that make?
Isn't there only 3 x squares instead of 4?
X to the 9th. So if you count 2, 4, 6, 8 plus 1 makes 9. So there is 1, 2, 3, 4 groups. Okay. All right, and then this ended up making, you guys said -24, x to the 4th, and then root x. And that's your answer. Yes? Because when you're like, if you had, like x plus x, what does that equal? X plus x? Yeah, x plus x, this is like 1x plus 1x, which would make 2x. That doesn't become 2x squared. When you're multiplying it, it becomes x squared. But at this point right here, we are just adding those together. So you keep your root and your exponents all the same, and you're just adding the numbers together. Here, when you're like bringing things out, you're multiplying it to that number. So that's when you like are adding the exponents that are there. Are we okay? All right, example 7. Yes? Okay. If you're ever not sure how this breaks down, I notice that it's an even number, which means I can divide it by what? 2. So this is 243 times 2. Okay, do you guys know how to check to see if a number is divisible by 3? You add each of these numbers together. So 2 plus 4 is?
8.
No. 6? It's okay. And 6 plus 3 is? 9. Is 9 divisible by 3? Yes. So if you count the digits up and that number is divisible by 3, then the original number is divisible by 3. Okay? So 243 ends up being 3 and 81. And then 81 we know. And if you look, you can double check that method. 8 plus 1 is 9, and 9 is divisible by 3. Anyways, 81 we know is 9 and 9, and then each of the 9s are 3 and 3. Okay, now how many do I need for a group here? 5. So we have a group of 3s, and we have a 2 left over. So that ends up being written as
3 square root of 2.
close. 3 fifth root of 2. Okay, and then 64. What two numbers multiplied by 64? Okay, 8 and 8. And we know each of the 8s break down to 2, 2, and 2, right? So I'm going to break this 8 down to 2, 2, and 2. And this 8 down to 2, 2, and 2. And we need how many 2s? 5. And it looks like we have 5 with 1 left over. So we write that as 2 and the fifth root of 2. And they are the same root, so I can add those together and we end up with 5 fifth root of 2. That's our answer.